Thank you very much, ma'am. I'll share the presentation now. All right, so very good morning to all, and it's my pleasure to share my experience on the n-dimensional building information modeling and its implication in construction 4.0, right? And this is basically a theoretical portion of BIM, followed by my experience, and we have done a lot of projects on BIM, so I'll share some of them. It'll be useful to you and also as a motivation to take us building information modeling as a serious thing in construction or civil engineering, right? So I thank Department of Civil Engineering, St. Joseph University, Nagaland, for giving the opportunity. So without further ado, let's get started. Right. So this is the outline of the presentation. First, we'll introduce BIM, what is BIM, and its nomenclature, etymology, and definitions. And then we'll talk about a little bit on the evolution of BIM. So the BIM which we not the same information model. We talked about different types of models, then basics of them, and finally we talk about LOD, level of details or level of development, right? And then there's a very important part, which is the construction 4.0. For some of you, it will be pretty new, and some of you are experienced with construction 4.0. So, in order to have a clear-cut understanding of 4.0, I'll introduce you what is Industry 4.0, then its implications in construction, which is basically the construction 4.0, right? And then we'll talk about BIM and its extension, like how do we make use of BIM and its versatility, and how do we extend it to further, enhance the functionality of BIM to a greater level. So that's a basic core idea of today's presentation, right? So before we get into the construction 4.0, let's talk about BIM. So BIM, in the sense like it's an acronym. It's called Building Information Modeling, right? So it could be called as Building Information Modeling, with modeling being a single L. This is how the Americans prefer. So the American Society of Civil Engineers or people, who works in universities in America, they prefer like building information modeling with an American spelling of modeling to have a single letter. In fact, this gets used worldwide also, even in our country and other countries. They prefer the same spelling, which is building information modeling. But sometimes in United Kingdom, they prefer to have a 2L. It's a British English, so they have double L for modeling. But either way, it's the same. So there's no difference. And if you want to follow the nomenclature like an American, then we follow this and thing. But basically, we abbreviated to BIM, Building Information Modeling part. So let's take a look at what is BIM. Whenever we wanted to find something, we just go to Google, and the first thing that pops up is Wikipedia, right? But if you go through the BIM from its origin, you could probably see the definition also got evolved. Like initially, in the year 2014, where like building information modeling were popular, and it became order of the day for construction project management. And Wikipedia at that time, it's just a process of generating and managing building data. So it does not have any other details, but it just say it's just management thing, or it's just like how you manage a building perspective. It's that's how it has been, right? In later in 2017, they have revamped the definition. They involve like generation and management of digital representation of physical and functional characteristics of places. This is where it's a very comprehensive definition, and it's they look into the physical as well as the functional characteristics, the energy analysis, the sustainability, all those things has comes into the picture, right? So BIM is no more data generation stuff, but it has got its own implications, right? So in 2017, they just had an idea of incorporating all those things, right? Then this is a current definition. Even if you go to Wikipedia today, you'll find the same definition. So it's just an addition. They just build a concept based on the definitions or the prior definitions, and this is the same, right? It is also now various tools. Earlier, BIM was a process, but now it is managed by various tools and technologies, and in fact, contracts being put into the application of BIM, right? So it's become a more of a comprehensive step. Say whatever in a construction, being it a design, being it a construction, or even a contract, everything gets placed in BIM nowadays. Like so, that's why it's a. And then the classic definition of generating and management of digital representation of physical and functional character of places. So this is the current definition of BIM, right? So what we're gonna try to achieve in this 1 hour lecture is we'll be focusing focusing primarily on what is BIM and how do we make use of BIM for our project and what exactly is the implications of that in construction 4.0. So that's a basic, application of BIM nowadays, like from there. And Autodesk, which is a very famous, software company for civil and other related fields, and they define it as an intelligent 3D model-based process. So in a Wikipedia, we just got only process, but they have defined it in a greater sense, like it's an intelligent 3D model, and then it is used for architecture, engineering, and construction professionals. Right. So as I told you, now BIM is a holistic perspective. They look into planning, design, construction, and even managing buildings and infrastructure. So this is a comprehensive thing. Now building information modeling has evolved to almost all the fields in construction. So it's almost an unified or a holistic perspective than an individual entity in a construction project. Right. And do not get carried away when we talk about BIM as building information modeling. The building information models are also abbreviated as BIM. So as I repeat, BIM not only stands for building information modeling, it also stands for building information model, right? So which is the model which we generate out of the process. So building information modeling is a process. The outcome of that is a model, and that is also we generally called as building information model or BIM, right? So this is just tricky term that many people confuses often, but do not get carried away by the process and the end result, right? So sometimes people use the extra s to represent that's a model, right? Models generally it comes in a different files, so file formats, like it gives you RFA file, RVT file, then many files like even Excel file, the schedules being exported to Excel file. So it is almost different computer files. Now, in order to differentiate BIM, building information modeling, now we have got building information models. So BIM, yes, they have added so that it is a different entity. So now there's no confusion. BIM is a process, but BIMS is the model, right? Something like that, right? So what are the models? It is a building geometry, then spatial relationships, then geographical information, and quantities and properties of building components. So this geographical information is very much useful nowadays. Most of the projects gets managed, not on that place or off-site. So, for example, if somebody manages a project in Kuwait or Germany. So if you can know the weather details, then you can incorporate there. If you want to incorporate weather details into your model, then you can put in your location, the latitudes and longitudes, and probably the software fetch the details from the cloud. So it's as simple as that. You don't have to really go to that particular place and do the modeling or construction process anymore. So that's what it says, geographical information and quantities. Like earlier, we used to have a multiple softwares to manage one project. Say, for example, for drawing, you need an AutoCAD, or then you need any other CAD programming. Then execution for analysis, you can take Stat Pro or something. And then finally, for construction management, you use MS Project or Primavera. Then for quantity estimation, you may use Excel or any QS Pro, something like that. So now you don't have to have a multiple softwares. A single software a single BIM software can replace all the individual softwares. It's just a comprehensive package now. So that's why we call BIM as a comprehensive, building information model or comprehensive models, right? Something. And it is like those are computer files and can be extracted, exchanged, or even network to support decision making to build assets. Something. So it's given to people, client, even your own construction personals to manage that and modify that. Once you modify that, it gets notified to all the people. It's as simple as that. Technically, it is called work sharing or collaborative construction. So we'll be talking about that a little later. But building information model or comprehensive models. Right. So before we get into the BIM modeling and something like that, let's take a look at the evolution of BIM. Right. So in fact, BIM was not developed solely, but it was the modification of various other related entities. The first thing being a CAD. So that is by Dr. Evan Edward Sutherland. During his time in MIT, he has developed revolutionary CAD program or CAD project called Sketchpad. I think many of you will know what is that Sketchpad. If you wanted to learn further, I'll share the slide and there's a Google link. It's a video. You can take a look at that. Probably that will give you more insights on Sketchpad. But this is the first program, computer CAD modeling software, or even you can call this a program, and they have developed to to make the draftsman's life easier or something like that. And this is a revolutionary program because that was the first attempt on CAD program or CAD softwares or something. And he was regarded as the father of computer graphics. Even if you take any movies, Hollywood movies, any animation movies, we have gone to a greater level of technicality or something. We have grown because of the initial sketchpad thing. So that was the revolutionary idea, which in fact changed the way which we think or which we do in terms of programming, in terms of animations and so right. And then building models. The first time building models. In fact, earlier it was called prototype or something like that, or model, just a model. The first time people called building model is in 1986. During 1980s, it was very popular because personal computers have comes into picture, like the IBM, like the Macintosh, the earlier Macintosh, and the Microsoft got its softwares ready, so that like during 1986 the personal computers are very popular, and then the term building model has comes into picture. Then the first time the term building information model was given in 1992. It's a very good paper. You can read. It's in Automation and Construction Journal, Elsevier, by Nederveen and Thalmann. So those are the people who have first coined the term building information model. From that point onwards, it becomes very popular, and even nowadays, it's a common term. Right. Then Autodesk, which is a pioneer building information modeling or softwares related to construction and related field, they had released a white paper in 2002. So that was a very, very interesting paper. So you can take a look at that. And initially, before that, or during that time, BIM was called by a different name. Earlier it was CAD, then become a building model, then it becomes a computerized model, then it is called generative component. It's called GC. So Bentley, it's a company which produces analysis package and very good software tools for construction. They have coined the term called generative components, or they probably used something called generative components, but that is actually BIM. So in a nascent form of BIM was generative component. Then Patrick Schumacher, and he has developed a term called parametrism. So this is a very, very interesting thing. In 2008, he has developed a term called parametrism, which means that if you change a component or change entity in a model, in a 2D model, say, that gets reflected in 3D and also reflected in the schedule. Schedule in the sense is the quantity take up. So which means that the entire workflow is so easy that you don't have to do multiple modifications for a single change. So that's a basic term called parametrism. So we'll take a look at that a little later. But as of now, understand that BIM has become more popular because of this parametrism, right? So if somebody works in AutoCAD, if they make changes in 2D, and if somebody makes a 3D AutoCAD and then CAD diagram, they have to make the changes. They have to do separately. And then who takes care of quantity estimation, and they also have to do that particular changes. If any one misses, then that will become an hindrance, and the projects, the flow of the projects get cut, or it becomes very poor or something like that, and it leads to a lot of chaos and confusions and something like that. So the accountability of the modification and the changes were very important, and BIM will give you an ease of that changes. That the term is called parametrism, right? In India, we call this to be virtual design and construction. Even nowadays, also, even in 2021, some companies refer BIM as virtual design and construction (VDC). But even the whole world have changed to BIM. But then few companies still wanted to retain it because they have done a lot of works in the virtual design and construction, something like that. But BIM is almost a comprehensive thing. So that's what we're gonna try to say, right? If you're a student or if you're a research scholar, then if you do a project on BIM, that will fetch you more credentials than any other stuff related to construction management or construction project or something like that, project management or anything related to civil engineering. Right. Right. Then in this lecture, we'll be talking about the interoperability and BIM standard, how we make use of BIM, the compatibility with the other related stuff. And then we talk about visualization and communication. This is a very, very, very important thing. Like how do you manage your project, virtual project or your BIM models across the globe, which is called collaborative or cloud-based work sharing. And then sometimes nowadays augmented reality and virtual reality are very popular. So we can make use of our BIM models directly than our CAD models because that will give you more insight. Supposing if you're a real estate agent and if you wanted to sell a property, say an apartment, so nowadays owing to COVID, like the physical visit may not be possible. So what you can do is you can generate a 3D model in BIM and you can make it into a virtual portal, say a virtual reality portal, so that the customers or the clients can view it in their own places. So they don't have to really go to that particular place and view that. So that's a very, very important thing that BIM is capable of, right? So incorporating into a virtual reality and mixed reality, basically mixture of augmented and virtual reality and something like that. Then we talked about macro BIM. Earlier, BIM was just, you can even see in the definition, it was just, the places. It was just the places. Whereas now it is an infrastructure. It's an overall thing. Like it could be a bridges or it could be any infrastructure, right? Even a light infrastructure or heavy infrastructure. So it manages everything. So that's why we talk about nowadays a term called macro BIM. So BIM is no more a micro, which is within your computer. It's a macro BIM. It's across the different computers and across the different peoples, working on it and something like that. So that's what we call Macrobim. And now people incorporate GIS into it, and that will be useful for remote sensing and other related stuffs. Then Green BIM for making and good urban planning or satellite city, green initiatives, and so on. Like sustainability gets incorporated into BIM. Then nowadays people use artificial intelligence also. Like they don't have to do the step once again from the scratch. They can create macros, or the computers can also learn by itself. Say for example, if you do a lot of projects in a particular BIM portal, then it will learn from your work experience, and then next time when you just say input, you give a lesser input or a vague input, it will automatically generates model for you. So that's a very advanced concept, but that's BIM can also be capable of doing that, right? So that's basic intelligence. And when I say building information modeling, it's the information of the building gets stored in a computer file. So you can perform data analysis. Say, for example, if you construct a building in 2008, and then if you replicate that same model nowadays, you can compare the price structure which got varied. And if you want to quote or if you want to apply for a contract or give a tender, so you can make use of the existing data, the historical data. So that's what basically means by the data analysis and something like that. Right. Then these are the terms that you should know for building information modeling. In fact, building description system by Churchman in 1975, and Glide, which is graphical language for interactive design, which is 1977. But those things are obsolete now, so it's no more in use. But understand that the evolution of BIM happened in 1970s or some before 1960s onwards. Later on, after the advancement of BIM, after the white paper got released by Autodesk and other components of BIM gets developed separately by other companies. We now call building information management also. Instead of model, we talk about management or building knowledge management, and sometimes construction information modeling. So this is a current term. Even nowadays, many people replace building information model because building they look into only a building. So the term building is just seems like a single value. But construction information modeling, it looks into everything. It looks to all the other aspects like the environmental aspects and even many things like the transportation into picture, like how do you transport materials and something like that. So those are called to be a construction information. In fact, if you want to do a research or if you want to do a project, finally a project, you can very well take on construction information modeling, right? And in some countries, they use a term called civil works information model, but civil information model or construction information model are almost the same. Like civil works information modeling is like that. Like they take the irrigation projects and the hydro projects and the dam construction and so on. So they put into civil works rather than construction being even a military construction also. So they wanted to have a separate term called civil works information modeling, right? Something like that. So these are the different names now BIM is referred to, right? So because of its comprehensive nature and also its high versatility to adapt to a lot of different functionalities. So they have named it by the different terminology. But BIM is the parent thing, like it is the source of origin for all these different terminologies. Now let's get into the basic modeling. Before we get into BIM, so let's take a look at the basic modeling. First, this is the evolution of building models. Initially, people used to sketch that. Even if you go to the Greek period, those diagrams are still in existence. Like they only sketch that. You can pretty well refer to Leonardo da Vinci and people like Galileo. They have just sketched their inventions and stuff like that, right? Then later on, 2D CAD were developed. Probably the Sketchpad was the origin for this. In 2000, I mean not 2000, 1960s, they have got this 2D CAD getting developed in a nascent form. Then we talked about 3D CAD. It's a wireframe model. So the 2D gets generated into a 3D form, but even then the visualization is just a 2D. But the stick model they developed during that time is called 3D CAD. It's also known as wireframe model, right? So at that time only 2D BIM were developed. So at that time 2D BIM were developed, and then they went into a further called 3D solid modeling. They looked into the surfaces and the designs, and then 3D BIM were very popular at that time. So shared parameters, which is the collaborative thing that I showed you, or parametric modeling. The NURBS is the non-uniform rational B-spline surface. The complicated surface can also be modeled using 3D BIM, whereas modeling of those sorts in 3D BIM are very, very, very difficult. Right. So then later on, they talked about 4D CAD, which is just 3D CAD, which is the 3D CAD wireframe model, plus the scheduling. It is not 3D solid plus scheduling, it's 3D CAD plus the scheduling. Right. They incorporate time frame into it. Say the mechanical engineers, they do simulation study and all, right? So they use CAD model with the scheduling and something like that. So that's basically an entity. And after that, the CAD modeling or solid modeling gets stopped. So 4D CAD were very popular at that time. But after that, we as a civil engineer have not much, uh, usage of 4D CAD and above. So we switched to BIM because after this is a revolution. When 3D BIM is done, we had got 4D BIM, which is 3D BIM plus scheduling. It's a time frame added to it. So then it is 5D BIM, which is nothing but 4D BIM plus costing. Right? It's not 3D BIM plus costing, it's 4D BIM plus costing, which means that 4D is nothing but 3D plus scheduling. So it means almost everything. Then 6D BIM, which is the 5D BIM plus sustainability. They looks into the energy analysis and something related to that, right? So that's called sustainability. And 7D BIM, which is 6D BIM, which includes everything plus facility management. How do you manage your asset? So all those things gets into place. That is called 7D BIM. And 8D BIM is nothing but 7D BIM plus safety. So nowadays, we only have 8D BIM. Maybe in future we may have 9D and n-dimensional BIM. There are a lot of research happening to incorporate other factors also, like the fabrication and everything related to construction also can be put under the BIM at the higher level of dimension. That's why I call ND BIM. It is n-dimensional. So now you probably would understand the core concept of this lecture. The title is ND Building Information Modeling. So we talked about 2D BIM, 3D BIM, 4D BIM, 5D BIM, 6D BIM, 7D BIM, 8D BIM, and n-dimensional BIM. Right. Right. So this is the evolution of different building model. Right. So this picture is a very famous picture. Like if you want to know BIM in a single picture, you can take a look at this. It all starts with the conceptual programming, in the sense listing down the different activities that could probably useful for constructing a project. I mean, constructing an infrastructure, right? So we note down like we need this particular thing and we need to have this area, this much area for this or something like that. Then we'll do a conceptual design. We'll make use of this and we'll generate some vague, it's not a complete design, it's just like a sketching. Like we do appropriate design, and we'll take a look at that. Then we will be looking into detailed design, when which we look into the member size, member thickness, and so on. Then we will analyze that particular model for the loads and the built, the external environment, say seismic or wind or something like that. Then we document everything from the scratch from this, and by this time we'll have got a lot of options, and we make use of that options and something like that. So by this time we will be performing the documentation, and then we look into fabrication, like what is required for this particular construction. Then 4D and 5D, which is the time frame which we construct that building, and also the cost parameters. And then it's the logistic, how you manage the debris from the site to the outside, or how do you manage the raw materials for the construction, this fabrication to reach the construction. Then we will do construction. Then once it is done, we don't stop that, we will look into operational maintenance also. How do we make use of that building asset, that everything is BIM, right? It's just information of that particular building from the scratch. Not only to the scratch, if the building after some years it could be demolished or it could be renovated. So till then, renovation or demolition, that's why there's a two track. Up to this or up to this, either thing, it gets stops. So building information modeling is a holistic thing. That is why people refer this to be a life cycle, so during its life cycle or project life cycle. So that's how it is, generally is. This is a good definition.
Hello, Murthy.
Hello. So this is a quick definition of what is BIM. Right. Now, many people have asked me, even in my previous lecture also, like what are the softwares available for performing BIM for construction projects. These are the popular softwares like Autodesk Revit and Navisworks. And nowadays we have got additional component to Revit called Dynamo and BIM 360. Then Vectorworks Architect and Tekla structures, but it's very expensive. And Graphisoft ArchiCAD, then Nemcheck Outpad. We have even used Nemcheck Outpad. You can even request for a student version. Then LOD Planner, then Power Project, which is the recent development in terms of BIM software for construction. And Week Office has been there for quite a long time, and even some of our students have requested for student license, and they have given us, and people have done their master's thesis using Week Office. You can even perform 5D cost analysis also. But if you ask me, the very popular is the Autodesk Revit and Navisworks, and more importantly, they give it for free to students for 3 years. So after 3 years, you can even get the newer version for another 3 years, and as simple as that, right? So that's how it is becoming a very popular thing. And I've used Autodesk Revit from 2009 itself, and I've seen all the versions of Autodesk Revit. Initially, it was like Autodesk Revit Architecture, Revit Structures, and Revit MEP, but now it's unified, which is Autodesk Revit. And another thing is called Autodesk Navisworks or Navisworks Manage or Navisworks Simulate. They can perform the 4D construction analysis, right? Something like that. So we'll talk about that a little later. So I prefer, or I suggest you can go and use Autodesk Revit and Navisworks. And this is what nowadays the Revit suite, which is the architecture, structures, and systems, which is MEP, mechanical, electrical, and plumbing. Now, if you download Autodesk Revit, the entire thing comes as a unified package. Or if you want to specifically use only architecture, you don't use structures and systems, you may not have that much space in your computer to use Revit, because it requires high graphics card, and the software itself is very heavy, more than 10 GB. So if you don't have the space, but if you're working with only you know architecture, then you can probably download this, or Revit LT for cloud sharing and work sharing and all. They can use Autodesk Revit LT. And then there are the auxiliary softwares like Autodesk Format and Autodesk BIM 360, when you can even visualize your model BIM models. Even you can use a mobile phone to download these apps, and you can visualize the models generated using the Autodesk Revit one. And this is a very important thing. So I want to share with you. It will be benefitable for student community. So you can go to Google and type Autodesk Education Community. That will take you to this page, and it will navigate to this thing. It's called Free Software for Education. Then you can, once you log in, register, they will give you verification code, and if you click that, and this will take you to this page. And if you can see the installation type, it's an individual or a class. So individual is an individual as a student. So you can click that, and you can go to particular software for Revit, for example Revit. Even AutoCAD and other softwares are free. So there are huge numbers of Autodesk. It's free for students for 3 years. And then you can click this, and you can but you have to put your name, then your student. If you're a student, you have to provide a transcript and a school issued confirmation letter and a student ID card and something like that. Then they will give you the it will take something like 48 hours, probably 2 days time. Then after that you will get the the license. Once you get the license, you can click go to that same page. Then you can get the product. You can do installation. Now 2022 has released. So when I screen captured it, that time it was the latest 2021. And it is like the year 2021 means the release will be 2022. It'll be a version ahead. Like for example, if we are in 2022, then the release will be 2023. So as simple as that, right? And you can directly install it, or you can download it. If you have a good bandwidth, you can download it 10 GB, or you can directly install from the cloud, because that will take only few MB of file downloaded. If you click that, if you have internet connection, it gets directly installed, right? And then for colleges, for classes and lab, you have something around 1,000 plus licenses Autodesk gives. So you can incorporate this. I can get the licenses, provided you give the valid letters and teachers to Autodesk, submitted via online itself. Then they will verify that, and they will give you credentials, and you can use that for your laboratory or something like that. So that's basically what we talk about the software. Now we'll actually get into the real concept of what is level of details or level of development, right? So the level of detail or level of development in UK they call it level of details, and whereas in the United States they call level of development, right? So in UK it is like LOD 1, 2, 3, 4, 5, 6. I mean 6 and 7. But in United States they've got LOD 100, LOD 200, 300, 350, 400, 500. And these are the different stages. You remember the diagram which we talked about, different stages using BIM. So these are the different level of developments or level of details. Like say for example, if a client wants only the analysis stage, I don't want to have a BIM model of this sort. I only need up to the analysis stage. You can pretty well stop with the design stage itself. But if a client wants to have it till production stage, then you have to give LOD 300 or LOD 4 in case of UK. So this is how it is, like from abstract, the conceptual thing. That is not there in United States. That's why it is hyphen. So, but that is there in UK. It's called LOD 1. Then conceptual stage, which is this is nothing but the programming thing that we just saw here, the programming stage, and probably LOD 1, 2, and it goes on till 7, right? LOD 7. We have got no different thing, right? So in use is the maintenance and operation phase or something like that. So this picture illustrates that this is just an LOD 1, LOD A or something in terms of Italian perspective. And as increases, if you say the LOD number increases, how comprehensive and detailed the buildings are. Like it has just a layout, and then it has just a geometry, not even appropriate geometry, vague geometry. Then they look into a defined object. Then up to here you can see the specific objects or fabrication, and this is a specific environment condition construction, this LOD 5. And then LOD 6, this is the almost more detail. And this is the final thing, LOD 7, which is the very detailed, and have got huge updated objects or something like that. So this is how the the level of development or level of details are. Right. So far I've talked about basics of building information modeling. Then we talked about different level of details and development. We'll now get into the core business of building information modeling. From this point onwards, I'll share my experience. But before we get into that, let's take a look at the evolution of building models that we have generated throughout the years. And so this is a movie, actually, a movie clip, a Tamil movie called Kathi. It's a prisoner escape scene when which one of the prisoners gets abscond from the central prison, and the policemen were very difficult since they are hiding. So they use another ways on this thing. So that it is just like dining room. So he asked for a blueprint to get how he abscond. He just asked for a blueprint, and this is how they were doing from the initial stage visualization, right? So with a blueprint, he just see and estimates like how he might have the prisoner who got absconded might have gone or something like that. He might have taken this pond, and there's a manhole here or something like that. And he also gets, you can see it's very funny also, but he just thinks of underground structures also, like how you could have entered into the sewer line and got outside or something like that. So this is how people were doing the blueprint reading for years, but and then people talk about the physical model. This is from Chennai, one of the hospitals in Chennai. They have got their staff quarters. This is the model, physical model, and it has got the front view and the rear view and the side views. You can see the side views, and this is probably the models that it's still in use. Like many architects still prefer having a physical model before it's being constructed, but it's just a waste of money and time because the BIM has a capability to do a lot of things virtually than this thing. You see, this occupies spaces, and you can see if there's any modification in it, it will be very difficult to do. So that's a waste of time, money, effort, and materials, and so on. Right. So now we'll be looking into the BIM model, the basics of a building information model or BIM model. So this is a problem I typically give it to my students. This is just a 7.6 meter by 8 meters. This is a very, very simple building, which is having a windows of three types and two types of doors and slab on grade and RCC flat roof slab. Then we talked about guardrails surrounding. This is just to give how to make use of Revit components, right? So that guardrails or something like that. Let's take a look at that. So this is the floor plan, 7.6 meters by 8 meters, and having a door, uh, double door and single door, and windows of different natures, type W, type W1 and W2. Just a simple building. So do not worry, there's no kitchen or something like that. Just a building to practice, right? So this is an architectural game. You can see the elevation also. This is from Autodesk Revit. So that's an elevation. Then it's a 3D model. So this is a 3D model. So this is a very basic model. So they can do it within no time. Say, for example, they may take an hour time and do it this. And once they do it, they feel very happy because they could do something, even though it's a hypothetical model, but it gives them a lot of joy or something like that. So once they have a model like this or something like that. Now, after that, once they are proficient, they themselves practice different models. They take different projects and they do it on their own. Then I'll give this even paper we have published on this model. This is an intermediate model in which the actual layout is given. The rooms are given like study rooms and baths and the dining room, the hall, the living room, the kitchen, stores, and bedrooms, and you can see the porticos. So it's just like little comprehensive than the previous model, and they could able to do it with time. And in fact, initially we didn't have staircase, and during our discussion then we talk about having a staircase or something like that. So then we can have a parapet wall, and we'll make use of the the roof also. Then we talked about lintels or sunshades, which was not there early. So you can see in the AutoCAD diagram, it's not there. So these are the things that we improvise on our own thing. And later people thought that this cantilever slab is not pretty much promising because it does not have any support underneath. So then we talked about having a support, just like the architectural columns and something like that. And then people talk about water tank, so precast water tank or something like that. And also we have gone to a further level, like this is an architecture model. Then this is a plumbing or MEP model, mechanical electrical plumbing model, in which they have got the water closet, the wash basin, and you can even see the waters. I mean the fall waters, fall soil soil pipes and something like that. And this how we see the water from the tanks goes into the building and something like that. And we also talked about precast construction. Like what happens if this cast in situ gets constructed using precast construction? Then we talked about this precast, like this is a precast element. So we have completely revamped this into this precast because precast will be very difficult to have this curvature. Then we talked about the complexity and we provided the flat slab or something like that. And instead of having the staircase here, we moved it to the other way around or something like that. We tried different options, something like that. And then there are different types of precast also. Like this is a paper, you can even look at it. I have provided that in the reference section, so you can take a look at that. So in this case, we talked about the precast as a framed element and precast as a monolithic element. So that's two different things. We have tried the particular stuff like this, right? And then we get into BIM and construction 4.0, right? So in fact, I planned a lot of things on explaining BIM, but since one of time, so what we do is we directly get into 4.0, which is construction 4.0. Then with that, stuff, we will be explaining the BIM concepts as well, right? Right. So before we get into actually the construction 4.0, let's take a look at industry 4.0. In fact, that was the pioneer in terms of evolution, right? Since 1784, the industrial revolution, that people refer to industry 1.0. But we don't have anything called construction 1.0, 2.0, because what basically construction 4.0 is an implication of industry 4.0 in construction industry. So that's basically that. Then we talk into 1870s where the mass productions, the assembly lines comes into picture. Then 1969 where the automation happens, the computers and electronics are parallelly developing, which makes the industry automation and robotics were kind of enhanced. And now we have a cyber physical system. We don't have to really manage an asset or a robot at that place, but instead it can operate anywhere in the world. It's called cyber physical systems. Then Internet of Things, like how do you manipulate your or how do you make use of your equipment? Say for example, nowadays you can see the AC is being controlled automatically because of the temperature outside. It adjusts by itself, no? So that kind of things were called Internet of Things, like how it how the machine learns by itself and make use of. Make your life easier or something like that. So that's industry 4.0 till today. So implications of this in construction is what construction 4.0, right? So I just told you this is the cycle of industry 4.0. That is everything. These are the different components. We talked about cloud computing, we talked about augmented reality, robotics, additive manufacturing, simulation, Internet of Things, big data analytics, and horizontal vertical integration and cyber security. All those things, right? So industry 4.0. And implications of this in construction is what we call construction 4.0. So before we get into construction 4.0, I want to tell you that there's no international conclusion on construction 4.0. There is no forum or no proper evidence of construction 4.0, but it is just an application of industry 4.0 in construction, so remember that. But now there are a lot of research happening on the implication of industry 4.0 in construction, and one such thing is the digital transformation. So BIM is a digital transformation of stuff, right? Say for example, after this up to this probably people would have modeled building by physical means. Now after this, people look into the digitization of the buildings or something like that, right? And one book on construction 4.0 were recently published. It was an edited book by Anil Shavne et al. And it's a very good book which has got all the characteristics of industry 4.0, how it could be applied into construction 4.0 or something like that. And this is a picture, which is a very famous picture, which is the actual implications of construction 4.0, or it is just an applied industry 4.0 in construction. And this is, you can say, the future of construction. So the first is the prefabrication and modularization. Remember, like we talked about prefabrication here, and that's the first number one here. And number two is advanced building materials like eco-friendly materials, sustainable building materials, and something like that. And 3D printing. Nowadays, people look into 3D printing. Like IIT Madras have developed a lot of 3D printing stuffs. Like if you can go to their website and you can see they made use of 3D printing techniques to construction. And then they talk about autonomous construction or virtual construction. How do they give thing? Like if you can see in YouTube, like a lot of hauling process or excavation process are unmanned nowadays. Like they don't need people to manage these kind of equipments, but they use 5G technology and so on. And then it's augmented and virtual reality. They talked about the big data, predictive analytics, and so on, and wireless monitoring, connected equipment like the IoTs and all, Internet of Things. How do you manage that? Say, for example, the sensors nowadays is very popular, and automatic. Sensors in the parking area is very popular because when the car is moved, the sensors gets captured and then the lights gets on. So when the car is stagnant, then nobody needs a light. So there's no people, moving in a park or garage. Then there's no need of light. So it could be dark. So which means that you don't have to have a light in a basement being, lit for almost a day or something. So it be an energy, saving or something like that. So those are wireless thing. And nowadays in our institute we have got the wireless, you know. Um, and the water transport facility, so that for washing your hands, if you have the sensor based, then at that point only you get water. When the sensor, when your hand is not contact with that equipment and it's off, and you save a lot of water, right? So which is a very scarce resource nowadays, right? Good waters are very, in fact, pretty much scarce in most of the places. Then cloud based, or you don't have to save material. I mean, don't have to save files then and there, but instead you can save it on the cloud so that anybody can use at any point of time, right? So if I want to, like this lecture is an example of the online rendition part, right? So I do the lecture in Chennai, and you guys are in Nagaland, so you can see if it does not have a collaborative or online thing, then I should come there, and it takes a lot of time to travel. Or if you want to come to Chennai, it's a huge distance, so it's a modern day, no? It's pretty much something like that. Then 3D scanning and photogrammetry is something which is probably pretty useful to GIS and remote sensing. And finally, but not last but not least, is the building information modeling. So it looks into all the other aspects into construction. So it's a digital representation of all these things. And how do we represent that in a construction? So this is a typical schematic diagram of a construction 4.0, which is nothing but the applied industry 4.0 in construction sectors. And a digital twin. So you need to know about identical twins and fraternal twins, which means identical twins are almost look similar. Fraternals are like kind of a twins, but look different, something like that. So a digital twin represents a virtual model or virtual copy of your process, product, or service, right? The term digital twin was coined by Michael Grievous in 2002. He was a professor, research professor in University, Florida Institute of Technology, USA. And you can even see his profile in this LinkedIn. This is actually a copy or replica of your, building or a process, something like that. And this is our institute, and this is the photograph, the aerial photograph of the institute. So this is the entrance, and this is the academic block 1. This is boys hostel, and this is academic block 2. But this is a very old photograph, but nowadays we have got additional buildings also. And this is the girls hostel, and this is the international hostel, and this is a health center, and we have got green parks here, and this is also a park, and this is the car park. Now the car parks are very much improved, with laid down the different parking things and something like aerial parking, I think. And this is the ground, and this is the other area where people have their time. And this is actually a kind of a landscape, so it's not very clear here and something like that. So this is the Kelambakam to Vandalur highway. So Vandalur is a very famous place in Chennai, where they have the zoo. Vandalur Zoo is very famous, and this is how it is like, the aerial view, right? So in 2013, we have tried to capture this in terms of computers, which is the this thing. So this is how the entrance is, but it's not a very detailed diagram, but you can see the administration block, and this is the proposed model and something like that. And we have got a lot of other images also. Just want of time, I'm just not expanding that. And also we have got a lab sponsored by Ramco Cements, and they use their product called Hylex, which is the calcium silicate based boards. Instead of the particle boards or wood, it's a sustainable, it's an industry waste. They compress it in terms of board, and then that can be used in our office spaces. This is the component as the existing then in a 3D model. So this is how the 3D model looks like. And all these things are Hylex partition, which is the calcium silicate board, and also so is this. And then you can see the chairs arrangement and something like that. So this is under the construction, and now it got constructed. Maybe next time I might show you the constructed facility. So this is how you make use of your BIM model, to a greater extent. So you can give it to people so they can visualize it before itself. Like so, this is how people visualize. You see the highlights partition and something like that. All these things, right? So you see, it gives you a clear visualization than conventional 2D modeling like this. If it is given like this, and it will be very difficult to visualize that. BIM has a capability to enhance further or something like that, right? And this is one of the projects in Chennai. It's an apartment building, and this is the different phases of thing. This is phase one, got constructed. This under construction. This is phase two, which is recently got constructed. And so this is how they use aluminum formwork. It's called modular formwork, and we have modeled that using BIM. And you see, this is how the real building is during construction. You can see the aluminum shuttering, and you can see how beautiful and how detailed these diagrams are. That has given the engineers a clear-cut understanding. And we have got a lot of discussion with the managing director and the project manager who involved in the construction, and they really appreciate the this implications of this BIM. The diagram is just the 2D CAD, and we have exported that to 3D model, and then we incorporated this add-ons called formwork systems, modular formwork systems. So these are the modular formwork systems. And this is another view of it, like after it's being constructed. So this is how the 3D building model finally is like. And you don't have to really worry this is very complicated or something. Like this is done by myself and one of the students, so maybe 2 days or 3 days time, so not more than that. So it's as simple as that. And then people nowadays wanted to enhance the BIM to a greater functionality called augmented reality plus virtual reality. So augmented reality is giving you an experience, like if you have that gear to look into the 3D models. The 3D models gets popped up from a 2D surface. That's called augmented reality. And virtual reality is you yourself put into the virtually put into the space, and you experience that particular scenario. That's what basically called virtual model. But nowadays it's just a mixture of both. It is both augmented as well as virtual reality. Let's take a look at some of the examples that we have done. And this is the space planning. So we wanted to have this kind of a cooperative learning stuff in one of the institutions. Then we talked about how people get spaced here, like something like this is what I initially done, and something like how the spacings of this can be done. And then like you can see in the top view, and you can even talk about how different people sit together and what happens if they have a laptops. So it's a it will be an abstraction to the other people. So all those things get studied, and this is called space planning or something like that, right? So finally we looked into all the options, different options. What happened, this guy wanted to focus the board on this side and have the laptop, whether it will it will interfere in others workspace or something like that, and so on. So we talked about the angle, the maximum angle, and what happens if there's some other obstruction here, a column comes into picture, or an equipment gets placed here or something like that. Their school bags gets placed or something like that. We just looked into a lot of options. And also like during one of the times, like one of the counseling period, the college admission process, we had the admission brochure. So we thought of making pop out of this thing. It's an augmented reality. So they have got a mobile app, and if they scan this our brochure, then our entrance gets visible. So this is a very interesting thing that which I have made during that time, which is done during 2016. And in fact, a paper also got published in 2017 using this particular concept. And same way, I teach a course called Architecture and Town Planning, when which some people find it very difficult, like the concepts like the classical architectural order, which is the abacus, the Corinthian columns, and something like that. And in order to emphasize that, I've created a 3D model or 3D augmented reality model. This model gets developed in Revit, then it gets incorporated into Unity 3D, then it gets visualized using a 4D, right? So then we look into when people scan this particular reference image with their mobile phone with the app, then they can get this gets popping up virtually, right? Something like that. And this is the conventional building model. We have extrapolated it in 2017. Our building model, BIM model, you remember the one which I showed you early, the diagram, the Autodesk AutoCAD diagram. So that gets mapped into BIM. Then that gets exported into augmented reality. Then we also look into virtual reality, when which the same model, so the same model, the kitchen, probably the dining area, how it looks like, and they want to navigate or go inside, they can use this. And it's very economical thing. It's this week gear is just like 250 that time. So with the mobile phone into place and the model into the place, and this is very good definition. So you can even type in Boga et al. Implications of virtual reality or augmented reality, or in BIM using virtual reality or augmented reality in Google, you can find our paper, and this is one of the key concepts which we developed during that time. And this is how you see, if you want to change the color of this mat, you can do that, or if you want to navigate further, go inside, trace that, and you can still do it or something like that. Right, so that's basically the augmented and virtual reality concepts. Then we talk into the interoperability and open standards of BIM. Right, so interoperability is, as I told you, BIM is a comprehensive thing, right? So it looks into a lot of other elements into picture, but not only that, that model, the BIM model itself can be exported to wide variety of other softwares for further functionality. So that is what we call interoperability, which is like how it gets operated with. Say, for example, if you generate a model in StatPro, the output may not be used in most of the softwares, other softwares, but that can be used with Revit, Autodesk Revit, because that's a BIM package. So that's how it is, like we can take file from other source, and also we can make use of our files to other source for making a further, further, reasoning or something like that. So this is an extension called TTX, by which if you install that with Revit, you can use Revit with Rhinoceros or Grasshopper, which is a rendering software. And you can even use that to ETABS or SAP or Tekla or even Excel for exporting the schedule or something like that. And then this is a model which we proposed for our car park in our institute, multi-level car parks. So this is done by Anupam Ghosh and Sandeep Basag. I think both of them from northeast only, and then from they have made different implications, like they talked about in out, and this is also a very interesting thing. I gave a project for our students to create a beautiful restaurant or a hotel or something like that. So this is a very good of that. There are a lot of good things, but this one really pay a lot of attention. This is an open, and this is an interior launch or something like that. This is an exterior launch, and this is open sky, and this is a restaurant based in, like one person who's really good in the Chinese architecture. He just say these are the things they use in Chinese restaurants, and probably I'll show you in detail. So this is the open launch. During night time, they have got lightings. You can see all these things are done using Revit, and you can even see rendering and what happens if there's a real person or something like that. And this is the open sky. this is what I told you. This kind of a Chinese restaurant. Like this is pretty much having, a lot of this gets, this is an improvisation of a lot of things and something like that. It looks like a real photograph, right? So this is a render picture. And also we talked about varied other source. Like I remember I told you the rhinoceros and grasshopper. There's another software called V-Ray, when which the Revit model gets rendered to a very realistic perspective. You see the mountains, you see the landscaping. They've done it really. And also we wanted to try not only a flat slab, kind of this kind of slab. We tried a lot of different things. So in the process of learning, and then fountain and just like we have a Lamborghini or something like that. And so these are the different things that we tried in during a class or something like that. And we have a course called building drawing. After that, we have got something called a J component. In that course, probably initially we had a J component. Now we don't have it. That time we just made use of this thing. In fact, this was done even in 2014. Now the models, the students develop a very awesome, even more thing. But since want of time, I'm just restricting to a few images or the thing that which we have developed earlier. Right, so BIM and its extension. So this is a research thing, like probably I did my PhD in constructability analysis, when which I used Revit and I created an app extension and just use this. It's just called, if you open Revit and you have something called creating an add-on. So you can use C Sharp, VB.NET, Ruby or Python. So I use C Sharp. And you can do a lot of things. You can do digital prototyping, constructability review, just like how you incorporate the cloud computing and IoT in construction. Then you also talk about data analysis, like knowledge management, artificial intelligence into picture. Then automated procurement or billing, which is ERP integration. Then BIM and facility and asset management, and something like that. So it's a whole aspects that we look into. And BIM and academic curriculum, like we have introduced, in fact I was the one who were very instrumental in introducing the building information modeling during 2015 when the curriculum changes. I have introduced in one of the courses I teach is called building drawing. So I've just introduced introduction to building information modeling. Even in module 7 I have introduced class detection, which is the 4D BIM. So which is kind of a pretty much an important thing for the students, so that when they go out they have got their own view about this thing, and they have their experience from their college itself or something like that, right? So initially we were teaching with the AutoCAD, the conventional CAD diagrams, both 2D as well as 3D. But later on we incorporate a BIM also into picture. So we give some problems, like as I told you, they can create on their own. Like remember, this is the one in the initial stage of this thing. In the initial stage of this thing was this, and he wanted to have the hexagonal model, and some people want to have a circular model, something like that. So this is just a creative job. In fact, many people have even more brilliant designs and something like that. So in fact, one of the important of teaching the 3D model or 3D BIM to students is that they really enjoy doing that, rather than a conventional AutoCAD, which is cumbersome and laborious or something like that. And in this picture, I really like the enthusiasm, the happiness in the face of the students or something like that. Then BIM is not only a concept, it is kind of a job perspective also. Many people, many civil engineers, they wanted to know this. Wherever I go, I just tell them it is civil engineering is not only the brick and mortar, the site jobs, or only the design jobs. There are other facilities also. So one such a thing is this BIM, uh, that is called BIM managers or BIM management. So let's take a look at that. So the famous job portal is the Naukri, Naukri.com. Then in that case, if you go and type BIM, and then if you type MA, it could have management and managers, and you can see a lot of opportunities are there, like the training, BIM modeler. Sometimes it does not need any experience at all. Like so, freshers they prefer, and sometimes 3 to 8 years experience, and sometimes 8 to 13 years, 5 to 10 years. The pay package may range 8 lakhs to 12 lakhs per annum. So it's in Mumbai, and I see they look into BIM, Revit, plumbing, whatever we talked about, no? So the previous slides, all those things like the Navy's works, all those things. If you know this, then you can really shine better in this civil engineering field. And also, it is almost an IT based stuff, so you don't have to really go to site to do that. So something like that. So this is an opportunity for most of the graduates or something like that. And so these are the references. Like just put my papers. You can click on that and you can see that we have done a lot of things in BIM. And this is a recent paper which we have done for post-COVID civil engineer education, in which we tried a BIM model and how it enhances the understanding of civil engineering concepts during our online classes or something like that. Right. So I think that comes to the end of this lecture. So thank you for listening.